to the next topic, the key properties of the multimedia system. So what is a property of a multimedia system? Multimedia systems are computer controlled. They integrate multiple media types. Multiple media types la it will support, right? They support media independence. So once the thing is created, that will be imported and it will be given to any people, isn't it? Once the file they are making, that file can be shared to anyone. The media is just independent, right? They support the media independence. They can handle the discrete and the continuous data. What is discrete and what is the continuous data? We will see that. What is a discrete and the continuous media? So discrete media is text, graphics and the images. So text means text, graphics and the images. Is there any time needed to view the text? No. If audio means if it is a 2 minutes audio, we have to sit and listen to the 2 minutes, right? But this is not like that. Discrete media means thing will come to your phone whenever we want. We can open and close immediately. There is no particular time to wait for that. Time is not a part of the semantics. Continuous media means it is an audio or a video. Here the time dependency is mandatory. We need to depend on the particular time, because audio means once 2 minutes audio we have to listen up to the 2 minutes. 2 minutes video we need to see from the starting to ending. So these are the things. Next thing, what is a requirement for the multimedia? At least one discrete and one continuous medium required. So what is a discrete and what is a continuous? These three are the discrete, okay? Text, graphics, images, and here audio and video. So what we need to combine? These two should be combined with, these two, like any one should be combined with either plus audio or text plus video, okay? So we are having a video, that video down we are having a text, so text plus video, yes. So we are having a text here and we are having a text plus audio. So we are combining these two. So one is from the discrete media, one is from the continuous media, right? One is from the discrete and one is from the continuous. So either we need to add audio or a video, right? The same here also, the text will be combined with audio or video. The graphics will be combined with either audio or video. The image will be combined with either audio or a video, right? So this is the thing here. At least one discrete and one continuous medium required. So just in the simple word, the processors are not a multimedia system. So processors are different. So they are not a multimedia system. We need to process the thing which is there in the discrete as well as the continuous. We need to combine them and we need to produce the output, right? Then independent media. What is an independent media? Media stream should be independent. Means media stream should be independent means we should not depend on any media. So once the media is created, it should be feel free to move forward. So we can share it with n number of people. It should not depend you. Once you are creating a picture, you are sending some New Year wishes. So New Year wishes of 2026, you are creating a picture and you want to send it to everyone. No, whatever you have created, you will be like to send to everyone. When you are unable to send the picture to someone, how you will feel that? So you have created. After that, when you are sending, it should move from your mobile or your computer to someone else. That is called as an independent, right? Or no, that thing will work only in that particular phone. I cannot use that picture in some other phones or some other mediums, means it is waste. That kind of scenario is called as dependent. So here the data's media should be independent and no fixed temporal dependency. So there is no fixed dependency. We are not having any kind of fixed dependency. Allows flexible arrangement in time and space. So wherever the space is compatible, so according to that space we need to arrange the data. So these all are called as independent media. Independent media should have these qualities, right? Then computer controlled system means what? So media processing is controlled by the computers only. All the medias will be controlled by the computers only, and it supports the programming and interaction, right? So always the programming also will be there, interactions also will be there. Coding language they are writing, no? People are writing a coding, right? So the codings will be combined with the other interaction. The playback only systems are insufficient. So only playback means, so which is playing at the back of the screen, right? So playbacks only systems are insufficient. So these are the computer controlled systems, right? And integration. What do you mean by the term integration? Term integration means independent medias are integrated. Okay, fine. So what is that? Synchronization of time, space, and the content. Automatic updates across the media. So when there is a platform, the thing should be getting updated automatically, right? So automated updates across the media and the synchronization of time, space, and the content. All these things should be clubbed together. So this is called as a integration. So then networked multimedia system means it should be connected with a network, right? Network means, so we are having a connectivity of system, that is a group of system, it is called as a network, right? Enabling the sharing and the exchange of media. So when you are connecting with the network, then only you can be able to share the data. So nothing but an internet. If you are connecting this with the internet, then the data will be shared very effectively. If there is no internet, how you will share the data? So this is what we will call them as a networked multimedia, right? Then continuous medias and data streams. So what is a continuous media? Continuous medias are time dependent. It require the data streams and it is time critical processing, right? Means, so it will take some time. First it has to buffer, it has to load all the data. Buffering, you the term buffering, you know, I think, yes. So whenever you are downloading a picture or a movie, it will take some time to buffer. It will download slowly. One green line will come, according to that it will download. When the full thing was downloaded, then only you can be able to open it, right? So this is a thing in this. And the mechanism of data transmission. So what is that data transmission is about? So we are transmitting the data from one source to another destination. So here transmitting means what? Source to destination, the data will be transformed. Yes. So this is the next topic. What we are seeing is mechanism of the data transmission, right? So how the data is getting transferred from the source to destination. So multiple media we have seen, we are sharing the data we have seen. Then how the data is getting shared from the source to destination, that we are going to see now, right? So for sharing, we cannot put all the data together. So we cannot put one complete file, one big file we cannot post. Yes, when we are posting also, what the thing will be at the back, they will break them into small portions called packets, right? So packetization is the first point. In digital system, informations are split into the small units called as packet for transmission. Yes. So we cannot carry the data in our hand. Anyhow, when you are going for a shopping, you are getting a plastic covers, no? Yes. Plastic pockets. Pockets only we will say that. So plastic packets we are getting. In that packet, we are dumping the material, whatever we are buying. Then we are carrying from the source to the destination. Isn't it the same scenario here also? We are putting all the data into the packet, that packets will be sent from one location to another location, right? The flow, how the flow will be, the data moves from the source, that is from the sender, to a sink, that is a receiver, right? So distributed system means what? The source and the sink can reside on separate computers across the network. Yes, isn't it? Yes, the source will be in one place and the destination will be in another place. So both the data will be transferred from the source to the destination. So now we are going to see about the data stream. So what is a data stream? Already I have told you about the data stream. Temporal nature of this is, a stream is a sequence of a packets with a specific time components and a lifetime. So what it is saying about, if it is a picture, yes, the picture will be broken as a piece, small pieces. Okay. Then the each piece is there, no? Imagine like this. So this is a picture. The picture I have broken into these many pieces. This piece la what information I am having. This piece la what is the information. So next this piece la what is the information I am having. So like this. So pocket 1, 2, 3. Like that they will divide the things into a pocket. Yes. those packets will be sent from the source to the destination, but it should ensure that these many packets are there, no, those many packets are received at that end. When we are sending a parcel to our friends, I have sent 3 parcels. Did you receive all the 3 parcel? We are ensuring, no. The same way, here the data are getting divided and those packets are sent to the destination. So destination component computer will check whether how many packets are sent, how many are received, right? So for these things, we are having a protocol and all to identify all these things. So no need to worry about that. So how many packets are sent and how many are received? This is a major responsibility here. So the packets with the specific time component and a lifetime will be sent. And composition, packets can carry two types of media. What is that? One is continuous, another one is discrete, right? So continuous media and a discrete media. So what is a continuous? It is a time dependent data and like a voice or a telephony. Discrete media is like a independent data, like a text file transfer, right? So this is the thing. Temporal transmission modes. So what is that? How we are transferring the data, doing the transaction from one place to another, right? We are having some types of that, right? So first one is asynchronous mode. So what is that asynchronous? No timing constraint, means there is no timing constraint. So example, sending an email or downloading a PDF. Yes, if you are sending an email, is there any time to send an email? By this time only you have to send. Like that, any time is there? No. PDF, you can send by any time, no? Pictures, you will send to your friends by any time, no? So there is no timing constraint. And synchronous, so it defined the maximum end-to-end delay. Means, example, standard web browsing or a lower priority video buffering. So you are downloading a video from one place, right? It is slowly showing downloading 10%, 20%, 30%, 40%. It was stopped. It was not downloading more than that. So it will wait for some particular time and then it will show network error. Isn't it? Have you observed this kind of errors, right? So there is a time limit. Within this time, this thing should be done. If not, show us a error. So that is called as synchronous and asynchronous. So what is that? So guaranteed fixed time interval between the packets, right? So high fidelity 2026 8K live streaming and VR environments. So nowadays this live streamings are using this isochronous, right? So isochronous only they are using for the live streaming thing. Okay. So with the short fixed time they will send the data, right? So it should receive within the particular time. So what is the interval of the particular packet? What is a packet is about? It's about a data, right? So imagine I told you a packet. So in that picture I have shown like, so this image. The image is divided into number of pockets. Yes. So I'm talking about this packet now. So this is a packet. So what is the information it will contain? We told like one continuous and one discrete. So this packet, so how much space it is, how much timeline it will reach, is that all intervals we need to calculate, right? So strongly periodic in the sense the pockets arrive at exact fixed intervals. Example, every 20 milliseconds. So each and every 20 milliseconds, like this packet will be sent continuously until the video or audio, whatever we are sending, should reach the destination. Common in uncompressed audio PC. So when you are compressing, what do you mean by the word compress? Compress is nothing but when the size of the file is more, so just compress it to reduce the size. How they will compress it? Just to eliminate the unwanted spaces. Just they will eliminate the unwanted spaces and they will make the file to be more compatible. So this is what the thing. So strongly periodic means the time intervals will be fixed. So within that interval time, that packet should be reached. If not, then it will show it as a error. So each packet we are having a time limit of 20 milliseconds. So weekly periodic means intervals vary slightly but follow a general rhythm. So it will, that according to the size of the packets, it will be varying, but it will have some general rhythm. Aperiodic means so the irregular gaps, the data is sent as it happens. So whenever they want, they will send how much ever time it will take. So that is called as aperiodic. Then data volume. So what we are talking about is data volume. That is a size. So strongly regular. Every packet is the same size. So example, uncompressed SCD raw videos. So for no compressing of the video, just we have sending that raw video. So uncompressed raw video it is. So like this videos like uncompressing in the sense it will be having a more space, so we can divide them as a portion and each portion will be sent one by one in a stream. That is like a pipe water flow, how it is going on, like that in a stream we have to send the video. So weekly regular or irregular means the size of the thing varies depending on the content and the complexity. So packet size may vary depending on the complexity. And compressed MPEG videos. So MPEG is a format of the video, right? So fast action scenes need more data than the static scenes. Yes. So action scenes means it will be having a more movement in the picture. Normal scenes, it won't have that much of movement. The people will come, stand, talk, like that means no more movement will be there. But acting and dancing and fighting, all those scenes will take more activities involved in that. So obviously when more activities are involved, more data will be there, so more of the things will be involved in that, and more packets also will come in that picture. Yes, so all the packets should be sent parallelly. Talking about the quality factors, right? Quality factors of a picture. So the bandwidth, the pipe size, high resolution media requires massive throughputs, that is GBps. What is a GBps? It is a gigabits per second, right? So for 2026 standards, latency means there is a delay, the time from the sender to receiver. It's a critical for latency means it is a delay, right? So sender to receiver. Sometimes what will happen, like when both will be sitting together only, if you are sharing a file, it won't go immediately. It will take more time to reach, right? That is called as a latency, right? And the critical for it is for cloud gaming and video calls, right? Video calls la sometimes when they are talking we can't receive them as early, will be there will be a delay in their speaking. So when you are asking one question, their mouth will be like lip syncing won't be in a proper way, like that the videos will. So they will talk, but by the time we won't hear the audio, later on we will hear that audio. So that is called as latency. And jitter means it's a variation in arrival time, and problem means it causes the stuttering, right? So the data will be lost when that thing is coming, right? So solution for this, jitter buffers the temporary storage to the out of the when the video is coming online, won't if the data packets are not received, then we won't get the flow of information as such. So for that what we should do is like we need to buffer the data. That is why all the videos like you might have seen a line. Yes, when the video is playing, so when the video is here means up to here some gray lines will be there. So it means these many datas are ready, move. So when the datas are going on, that these are ready. So up to here no issue. So when the video reaches here, in the meanwhile it will download this much. So the flow of the data won't be disturbed. If not, if you are coming here, this data was not loaded, the video will be stuck up in this place. This is what the quality. And then so we are having some more qualities. Reliability versus the speed. So multimedia often prioritize the speed over the perfection. A dropped pixel is better than the frozen video. So what is that? So always multimedia means we need to be like with more speed, and it often prioritize the speed over the perfection. A dropped pixel is better than the frozen video. So when we are unable to detect that pixel will be dropped and match up with the something, and it will keep on moving, like it won't stop the video, like it will be keep on moving, it will put that related pixel and it will move the video, right? So interdependent bandwidth, latency and the jitter must all be optimized to provide the seamless user experience. So what is this? Here not a single man show. The bandwidth, latency and the jitter all should be like combined together to get a good quality picture.